Good morning, students. I am Dr.R.SUGANYA, Assistant Professor, Department of Computer Science with Cybersecurity. Today we are going to see about public key cryptography and about RSA. Public key cryptography, probably most significant advance in 3000 years history of cryptography. They uses two keys. One is public key, the other one is private key. So asymmetric since they are not equal, they uses clever application of number of theory concepts to the function. It complements rather than replaces private key crypto. So it is developed to address two key issues. So the key distribution is how to have the secure communications in general without having to trust a KDZ with your key. Digital signatures, how to verify a message come intact from the claimed sender. Public invention is due to Whitefield Diffie and Martin Hellman at Stanford University in 1976. However, it was known earlier in classified community. Public key or two-key asymmetric cryptography involves the use of two keys. A public key which may be known by anybody and it can be used to encrypt messages and verify signatures. A private key is known only to recipient and it is used to decrypt messages and sign signatures. Is asymmetric because those who encrypt messages or verify signatures cannot decrypt the messages or create signatures. Here we can see the diagram. So how the plain text is transmitted to ciphertext using the encryption algorithm, example RSA. The main example here is given the Alice Bob and public key ring is given. So it is being transmitted to ciphertext and again from ciphertext it is being transmitted to plain text using the decryption algorithm, that is a reverse of encryption algorithm. Public key algorithms relies on two keys where it is computationally infeasible to find decryption key knowing only algorithm and encryption key. It is computationally easy to encrypt or decrypt messages when the relevant key is known. Either of the two related keys can be used for encryption with the other used for decryption. Public key cryptosystems. Here the message source is given. So the same thing which is being used as variable where for the main source of plain text is being transferred to ciphertext, that is a source A, and that is being given using the variable pu and x. So x is a source message and the crypt analysis is being given in between the encryption and decryption algorithm. So key pair source is being used for both encryption and decryption, that is pu and pr. So here we can see the cryptosystem authentication and here authentication and secrecy. So the secrecy of the particular key pair source has been maintained for both encryption and decryption. So public key applications, it can classify users into three categories like encryption or decryptions which provide secrecy, digital signatures which provides authentication, and the key exchange of session keys. RSA crypto system. This crypto system is the initial system. It remains most employed crypto system even today. The system was invented by three scholars, Rivest, Shamir and Len Adleman, and hence it is termed as RSA crypto system. We'll see two aspects of RSA crypto system. Firstly, the generation of key pair and secondly, encryption decryption algorithms. Generation of RSA key pair. Each person or a party who desire to participate in communication using encryption needs to generate a pair of keys named as public key and private key. The process followed in the generation of keys is described below. Generate the RSA modulus. Select two large primes, that is P and Q. Calculate n equal to P into Q. For strong unbreakable encryption, let n be a large number, typically a minimum of 512 bits. Find the derived numbers, that is numbers e must be greater than 1 and less than p minus 1 into q minus 1. There must be no common factor for e and except for 1. In other words, two numbers e and p minus 1 and q minus 1 are co-prime. It forms a public key. The pair of numbers n comma e form the RSA public key and it is made public. Interestingly, though n is a part of public key, difficulty in factorizing a large prime number ensures that the attacker cannot find an finite time the two prime numbers, that is P and Q, used to obtain N. This is the strength of RSA. Generate the private key. Private key D is calculated from P, Q and E. For given N and E, there is unique number D. So number D is the inverse of E modulo. So this means that it has been applied, which is equal to 1 modulo. This relationship is written mathematically. So example is given, an encryption and decryption. So once a key pair has been generated, the process of encryption and decryptions are relatively straightforward and computationally it is easy. Interestingly, RSA does not directly operate on strings of bits as in case of symmetric key encryption. It operates on number modulo n, hence it is necessary to represent the plain text as a series of numbers less than n. RSA encryption. So the sender wishes to send some text, so whose public key is n, e. The sender then represents a plain text as a series of numbers less than n. To encrypt the first plain text P, which is a number modulo n, the encryption processes simple mathematical steps. C equal to P power E mod n. In other words, the ciphertext C is equal to plain text P multiplied by itself E times and then reduce modulo n. This means that C is also a number less than n. Returning to our key generation example with plain text P equal to 10, we get ciphertext C. C equal to 105 mod 91. So RSA decryption. So decryption process for RSA is also very straightforward. Suppose that the receiver of public key pair n, e has received a ciphertext C and receiver rises C to power of his private key D. The result modulo n will be plain text P. RSA decryption. It is very straightforward. It also has the same public key pair and the receiver rises C to the power of his private key D and the result modulo n will be plain text P. So here the example is given. So when we analyze the RSA, the security of RSA depends on the strength of two separate functions. One is encryption function, the other one is key generation. It is considered as one-way function of converting the plain text to ciphertext. And the difficulty of determining a private key from an RSA public key is equivalent to factoring the modulus n. The attacker thus cannot use the knowledge of an RSA public key to determine an RSA private key unless he can factor of n. It is also one-way function. Going from P and Q values to modulus n is easy, but reverse is not possible. So strength of RSA encryption drastically goes down against attack if the number of P and Q are not large primes and it choose public key E is a small number. Here are the MCQs. In public cryptography, the public key is used for. In RSA algorithm, the public key consists of. The security of RSA is based on the difficulty of. What is the relationship between public key and private key in RSA? In RSA algorithm, the decryption keys. Thank you.